So we are starting with integration, and under the integration should I say is the reverse of what they call differentiation. And basically, integration is about summation. It's about summation. So it's basically the reverse of integration. And so, for instance, if you're given something like 2x squared to integrate, to differentiate, you bear with me that you are going to get what? 4x, right? 4x.
Yeah.
And so if you are differentiating this, you are going to get 4x. Now, integrating this will give you the integral of the 4x is this one. So that means the integral reverses the differentiation. So if I differentiate this, I'm going to get 4x. Now, when I integrate this, I'm going to get 2x. I'm going to get my 2x squared back. So basically, integration is the reverse process of differentiation. I hope you get it.
Yes.
So if I said f of x is equal to 2x squared, then that means differentiating this. That means f prime of x will give me this by this. That will give me 4x. Now, however, you also realize that if I'm also giving 2x squared minus 2x squared minus maybe 7, when I integrate it, what I'm going to get? I'm still going to get the same 4x. I hope you get it. I'm going to get the same 4x because differentiating this will go to 0. So this will give me 4x. I hope you know that.
Yes, sir.
Now, because this is a reverse of this one, then because we don't want to miss the -7, you what do you call it? When we are integrating, we represent that by a constant, which is c. It can be k or anything, by a constant c. That is to say that when we are reversing the process, there are some instance, for instance, if I get this, if I have this and I differentiate and I get 4x, this same thing will still give me 4x. But I realize that the two of this one has -7, this one has no -7. And because here this was a constant, it will automatically go to 0. And so in order not to mess this, when we are integrating, we will represent this by a +7 that we don't know, like a positive c, not positive, like by a c that we don't know, so that in case we are going back, then when we are giving some variables, we put it in, we can find for the c and see if it was 2x squared we are referring to, or 2x squared minus 7 we are talking about. I don't know if you get my point. And so basically that is it. So this is integration is the reverse of differentiation. So if I differentiate this and come and get this, then I mean when I integrate this, I'll come and get this. I hope you've gotten it. When I differentiate
Yes,
this and
sir.
get this, when I integrate this, I'm going to get this, I'll go back to my position. So that is it. So likewise, so if I have 2 t squared, then when I'm integrating this with respect to t, I'm going to get 4t. I'm going to get 4t. Now when I integrate this, I'm supposed to get 2t squared again plus c. And I've shown you why there's going to be the plus c. You add a constant, you always add a plus c in order to account for any constants in what they call it, the reverse process or something. That is it. Now, you bear with me that I want to clean the board. So, still standard integration. Now, you bear with me that if you are differentiating, you normally write a y all over dx. You already know this. So when we are differentiating, we write dy dx. Now, when we are integrating, it's a summation, so it is represented by this. Instead of the dy dx, it is represented by this. Then we add a dx to it. If it is t, then it will be the t. That means, if under differentiation, if you are given the y, the x, then it meant that if y is equal to 2x squared, find the y dx, and it means that, or it meant that we are differentiating this y with respect to x, because we know that in this y we find the 2x squared. So we are differentiating everything in the y with respect to the x values in it. Now, when we are differentiating to, this symbol shows that we are integrating. Sorry, when we are integrating, it shows that we are integrating. We call it the integral sign, or integral sign, anyhow you want to say it. The integral sign, the summation, the integral sign, the integral sign. So then you add the dx, the integral sign and the dx. The dx means that we are integrating respect to x2. And so that is it. And so we are integrating respect to x. And so that is it. When we see this, then we know we are talking about integration. It dropped, it normally drops. And so please, so this means we are integrating. Then you add the dx. When we take away the dx, then we bring the plus c. That is after when integration is done. So let's write the general equation for, or the general formula for integration. Now the general formula for integration, that means if n is a real number, which is not equal to 1, then the indefinite integral of, and this integral you are going to do is, we have the indefinite and we have the definite integral. So we are going to talk about the indefinite, we are going to talk about the definite, then we do integral by substitution, then we do integration of sine and cosine, and then we are done for the day. And so that is it. So then the indefinite integral of f, so if I have x raised to the power n, the indefinite integral of this is given by, this is a sine x n raised to the power this dx is equal to 1 all over n plus 1 x n plus 1 plus c. So realize that it was to be integration, differentiation, we would have, what do you call it? We would have subtracted, but integration we are adding, and when we add, then we divide by the power we added. And so a typical example, I give the 2x squared. And so if I am integrating 2x, this indefinite integral or integration, indefinite integration. So 2x squared dx. Now when I'm integrating this, looking at this, it will be, what do you call it? 2x. Then there's a power. This n. Please, this is x. This is the n. So this is n plus 1. So 2 plus 1 will give me 3. All over, what do you call it? All over 2 plus the 3. Do you get it? Plus c. Plus c. Do you get it?
Yes, sir.
So there is it. Now, if you want to still get my 2x squared, that means we will differentiate the whole of this. When we differentiate the whole of this, you know that differentiation of a constant goes to 0. So this one will go to 0. Now this one will be 3 minus 1 times 3. Will be times 3. So this 3 would cancel this. So you come and get our 2x squared again. So that is it. So there's the formula. There's a formula we are going to use. There's a formula we are going to use. There's a formula we are going to use. On the other hand, we can still write this like this. It's the same thing. ax raised to the power n dx will be equal to ax n plus 1 all over n plus 1 here, n plus 1 here, plus c. That is it's the same equation like this. For instance, if you have to compare this and this, the a is the 2 and the x is what do you call it? The x now. So that is it. Is it like this one? Just that this one I bring, this one has a coefficient, right? This one doesn't have a coefficient. So this one will be like maybe x cubed for x squared. X, there's only x squared. But when you have a coefficient like 2, 3, or 4, 3x, then something like this. But it's the same format. Please, do you get it?
Yes, sir.
Oh, the rest will talk. Mildred, do you get it?
Yes, sir.
So we are going to do more examples so that you get it. So just don't worry. So if you have integrate maybe 3x cube dx. So integrating this will be 3x 3 plus 1 all over 3 plus 1 all over 3 plus 1 plus c. What are you getting? So this one will be 3x raised to the power 4 all over 4 plus c. Please, do you get it? Do you get it?
Yes.
Yes, sir.
Okay. Let me. So for instance, that's why I told you that integration is the reversal of this thing of differentiation. So let me give you a typical example. So when I differentiate 2x squared, I'm going to get 4. I'm going to get 4x. When I differentiate 2x squared, I'm going to get 4x. Now let me integrate this and see if I can come and get my 2x back. So this is 4x dx. Now this one will become 4x squared all over 2. 2 cancel this and cancel this. That plus c. But here we can just ignore the c. So we are going to get 2x squared like this one. So that is it. Let's do some more examples then. Now, I want to give you. So let's integrate 2x squared plus 3s plus 1. Let's integrate this. Into bracket dx. So when we are integrating this with respect to dx, what we are going to get is we are going to get this will give us an L differentiated. This will give us 2x raised to the power 3 all over 3 plus 3x squared all over 2 plus, when I integrate this will be x. If it's 7, it will be x. If it's 7, it will be 7x. If it is 8, it will be 8x. If it is 1, it will be 1x or x. If it is 2, it will be 2x. Anytime you integrate a constant like 1 or any constant, x will be added to it. And so this one will be x plus c. Then you add your plus c. Do you get it?
Yes.
Do you get it?
Yes, sir.
Okay, integrate this for me. Integrate this for me. Integrate root x. Integrate root x dx. Integrate it for me. What are you getting?
Sir, please. 2 over 3x raised to the power 3 over 2 plus c.
Is that it will be what? 2 over
3x
Okay, raise the power
3 over 2
3 over 2
plus c.
plus c.
Yes.
Good, 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 good. So this can be the same as, this can be equal, or this can be the same as 2 over 3. Let's raise the power cube plus c. Do you agree?
Yes, sir.
Okay, this is basic mathematics. Now do this for me. Let's do this. Determine minus 3x over 4x. Let's do this. When finish, you do this two for me. 1 minus. Oh, this is dt. Do this for me. What do we get? What do you get?
Say
I'm listening.
1/6 x cubed minus 3/4 x plus c
Good.
for the first one.
Good. Who else? Who else had the same answer? Rashida, did you get the same answer? Rashida,
Say,
did you get the same answer?
no.
Aku, did you get the same answer? Mildred, did you get the same answer? Mildred, did you get the same answer? So, for the sake of those who didn't get it or don't know how to go about it, you know that we can rewrite this one as the same as this. S cube all over 4x over 4x minus 3x all over 4x all over 4x. Now this and this can cancel. You can cancel this. Now when you cancel this, can also cancel this. So you will be left with x squared, and 2 go into this 1 and get here 2. So now we can rewrite this one before we integrate as 1/2 s cube, the x cube, right? Half x squared, sorry, minus 3 all over 4 dx. Now, when you're differentiating, when we are integrating this will give us 1 all over 2 times, this will be x raised to the power 3 all over 3 minus, this is a constant, so we add x to it, so minus sorry, I think the network. So that was 1 all over 2 x squared, x cubed, sorry, all over 3 plus, I think it's 3 over 4. So that'll be 3 over 4 x, 3 over 4, x plus c. Now when we have to rewrite this, it will be the same as x cubed all over 6 plus 3 all over 4 x plus c. So that's the same thing, or you can rewrite it at 1 all over 6 s cube plus 3 all over 4 x plus c. So when you're given integration division, just try and see if you can break them down before you integrate. Do you get it? Now the other ones you are given, we're given 1 minus t squared dt. You have to integrate this. Now we can, what do you call it? We can expand this and integrate. So expanding this, what are you getting? That will give me 1 minus
T
2t,
squared minus 2t
1 minus 2t plus t squared
plus t squared.
all into bracket dt. All into bracket dt. Now we have this, then we can now integrate. Integrating 1 will give me what? t, respect to the t, will give me t minus, when I integrate this, what am I going to get? That will be 2t squared all over 2. All over 2. So even a 2 and 2 will cancel. Plus, this will be t cube all over cube all over 3 plus c. So this will give me c minus t squared plus t cube all over 3 plus c. Did you get it?
Yes.
Hello, how many of us don't understand? If you don't, just tell me. Do this for me. When it cuts, you join again. Do this for me. Determine minus 5 all over 9 do this for me. What do you get? What are you getting? So let's do it together. So we are going to get, let's see if you can rewrite this. This will be minus 5 all over 9. This can be the same as t raised to the power 4 all over 3. Do you agree? Do you agree? Let's do t.
Yes.
So after getting this, then now we can do the normal thing we do. So we can just even isolate this. We can just write something like this. We can bring this one out. We can bring negative 5 over 9 out. So this can be negative 5. Sorry. 5 all over 9. So negative 5 all over 9. So that will leave us 1 all over t, right? All over t raised to the power 4 over 3.